In today's lesson, we'll be exploring the topic of arithmetic sequences. This lesson will cover and expand on syllabus dot points 321 to 324. Arithmetic sequences, also known as arithmetic progressions, are sequences of numbers that have common differences between consecutive terms, meaning each new term increases or decreases by the same amount. For example, the sequence 4, 6, 8, 10, 12. If we look at the first and second terms, 4 and 6, we can see there is a difference of 2. Now if we look at the second and third terms, 6 and 8, we can also see there is a difference of 2. Therefore, 2 is being added to the previous term to produce a new term. Because of this common difference of 2 between each term, we can recognise this as an arithmetic sequence. Terms of an arithmetic sequence can be expressed through formulas in terms of Tn. The first and most simple formula is called the recursive rule. It helps us find a term by using the previous term. It can be written through the formula Tn equals Tn take 1 plus d, where Tn is the term we're trying to find, Tn take 1 is the previous term, and d is the common difference, or amount being added or subtracted each time. Let's look at another progression. 3, 6, 9, 12, 15, 18. To find the common difference, we simply pick two consecutive terms and subtract the earlier of the two. Here we could take 15 and 12. 15 take 12 equals 3, so there is a common difference of 3. If we wanted to find the seventh term, we can use the recursive rule. T7 equals T6 plus D. T7 equals 18 plus 3, so the seventh term is 21. The general recursive equation for this sequence is Tn equals Tn take 1 plus 3. We then follow this with T1 equals 3 to create a definite starting point of the sequence. Otherwise, there would be an infinite amount of possible starting points and terms. You may have noticed there is a limitation to using this formula, however. It requires us knowing what the previous term is. This becomes impractical if we are asked to find larger terms in the previous terms are not given, like the 20th or 100th term. We could continue to write out the progression until we find the answer, but that wastes valuable time. Take again the previous sequence, 3, 6, 9, 12, 15, 18, and so on. The last term we are given is the 6th, which isn't useful if we are asked to find the 60th term. This is where the second formula comes in, written as Tn equals A plus, in brackets, n take 1 times d, where Tn is the term we are trying to find, A is the first term, n is the term number, and d is the common difference. Firstly, we need to find all our variables. A is genuinely given. D, however, we need to find by using the method we just talked about. So when we are asked to find the 60th term, A equals 3, n equals 60, and d equals 3. So T60 equals 180. This formula enables us to find a term in the arithmetic sequence, regardless whether the previous term is given. Arithmetic sequences can be modelled on graphs to display linear growth and decay, with linear just meaning the term being added or subtracted each time is the same, or there is a common difference. Let's say Liv has $200 in her saving account, and each week she buys a colour bomb on Candy Crush worth $5. The progression of her saving balance will be 200, 195, 190, 185, and so on. Now if we graph this sequence with the balance on the y-axis and the weeks on the x-axis, we'll see a straight line formed. We can also apply both the recursive and general Tn formula. As we can see, the gradient of this function is negative, so in this situation it is called decay. Now instead let's look at Homer's saving account, who works at JB Hi-Fi earning $20 a week. Assuming he starts with nothing in his account, his balance will follow an arithmetic sequence of 0, 20, 40, 60, 80, 100. Graphing this, we can see there is now a positive gradient due to the common increase of 20 between each term, and so the situation is gross. I hope this lesson has developed your understanding of arithmetic sequences and progressions. If you have any difficulties, please let us know in the comments below so we can clarify it for you.